Welcome to Creative World. In this video, we will solve Chapter 3 exercise problem number 3.12. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Ohm's law. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Exercise problem number 3.12. Use nodal analysis to find voltage V0 in given below figure. This is the circuit diagram of given problem. Inside this network, we have to find voltage across this 12 kilo ohm resistance labeled as V0 with this specified polarity. And we have to adopt nodal analysis techniques to solve this problem. So without wasting time, let's proceed towards the solution of the network. We know that in order to apply nodal analysis on any network, we have to follow some steps. First step includes finding out the maximum number of node voltage equations that can be retrieved from that network. So using this equation we can find that figure. In this equation n represents number of nodes in the network. So in our case there are two number of nodes. 2 minus 1 will be equal to 1. So maximum one node voltage equation can be retrieved from this network. In second step, label all unknown non-reference node voltage. In this case, this non-reference node voltage will be labeled as V1. In third step, we have to assume all unknown branch currents along with their directions. Direction of current through this 12 kilo ohm resistance was already given in this scenario, flowing from node 1 to 6 volt source. So we have just labeled this current as I3. Now we will apply Kirchoff's current law on this node to find out node voltage equation for this particular node. On this node, one current is entering while two currents are leaving. So entering current will be taken with positive sign while leaving currents will be taken with negative sign. In next step, we have to replace all these three currents with their respective equations. Current I1 is equal to 12 volt minus V1 divided by 6 kilo ohm. Because this resistance is connected between two voltage levels, so the difference of these two voltage levels will be equal to voltage across this resistance, and that voltage divided by the value of resistance will be equal to current through it. Now the direction of current is from 12 volt source to V1, which is indicating that 12 volt is higher than V1. That's why we have subtracted V1 from 12 volt. So current I1 equation will be 12 volt minus V1 divided by 6 kilo ohm. Current I2 will be equal to V1 divided by 6 kilo ohm. Similar case will be applied here. This resistance is connected between two voltage levels. One is voltage source of 6 volt and other one is node voltage V1. So the difference of these two voltage levels will be equal to voltage across this resistance, and this voltage difference divided by the value of resistance will be equal to current I3. Now in order to find the difference of these two voltage levels, we have to focus on the direction of current. Current I3 is flowing from voltage level V1 to 6 volt source, which is indicating that this V1 will be on higher potential than 6 volt. So we have to subtract 6 volt from V1. Difference of these two voltages divided by the value of resistance will be equal to current I3. Now in order to omit all denominator values, we will multiply this equation on both sides with 12 kilo ohm. Product of 12 kilo ohm and 6 kilo ohm in denominator will cancel out with each other. Only 2 will left, and that 2 will multiply with 12 volt minus V1. Here product of 12 kilo ohm will cancel out with 6 kilo ohm in denominator. Only 2 will left, and that 2 will multiply with V1. Here product of 12 kilo ohm and 12 kilo ohm in denominator will cancel out with each other. Only V1 minus 6 volt will left. Now open these brackets. Product of 2 and 12 volt will become 24 volt, and product of 2 and minus V1 will become minus 2 V1. Here minus will multiply with variables inside the brackets. It will become minus V1 plus 6 volt. Now add 24 volt and 6 volt together, it will become 30 volt, and sum of minus V1, minus 2V1 and minus 2V1 will become minus 5V1. Place this constant value on the other hand side of equal and divide on both sides with minus 5. The value of voltage V1 will become 6 volt. After calculating the value of voltage V1, now we are able to calculate the value of current I3 through this 12 kilo ohm resistance. If we succeed to calculate the value of current I3, we will be able to calculate voltage across this 12 kilo ohm resistance using Ohm's law, and that is the required parameter in this scenario. We have to find out voltage across this 12 kilo ohm resistance labeled as V0. So first of all, we will try to find out current I3. Current I3 is equal to V1 minus 6 volt divided by 12 kilo ohm. Replace V1 with its value 6 volt minus 6 volt divided by 12 kilo ohm. Sum of 6 volt and minus 6 volt will become 0, and 0 divided by 12 kilo ohm will result 0 ampere. So the value of current I3 will be equal to 0 ampere. So using Ohm's law, we can calculate the value of voltage across this 12 kilo ohm resistance, which will also be 0 because of the value of current I3. So there is no voltage appearing across this 12 kilo ohm resistance because no current is flowing from it. And the reason behind it is that there is no voltage potential difference between these 2 points. Here 6 volt is appearing and the value of V1 is also 6 volt. So there is no voltage potential difference. That's why there is no current flowing from this 12 kilo ohm resistance and no voltage will be appearing across it. So this was exercise problem number 3.12. Thank you. See you again in next video.